Solve the following problem by using simultaneous equations. State in words exactly what each variable represents. Set up two equations and solve them. In a collection of coins made up of dimes and nickels, there are 3 more nickels than dimes. If there is a total of $1.95 in the collection, how many of each type of coin is there? So this is a coin problem as well. Keep in mind that when we have coin problems and we're asked to solve these using simultaneous equations, we've already developed that there are 2 types of equations you'll be dealing with. The first equation will be dealing with the value of all of the coins. And generally this equation is made up of multiplying the value of the single coin times the number of coins. So for instance, if we are dealing with dimes, dimes are worth 10 cents. So we'll start off with 10 multiplied by D. And nickels are worth 5 cents. So we'll add 5 multiplied by N to get 195. Keep in mind, if we decided to use D and N, we want to be able to define it. So when we do that, we'll write that on the side. D equals number of dimes and N equals number of nickels. Also, remember that if you use 10 cents to represent the value of each dime and 5 cents to represent the value of each nickel, then we have to change $1.95 to 195 cents to be consistent. So that's the equation dealing with value. That's the one we're pretty much familiar with. Now, the second equation is a little bit more trickier. That's going to be the equation that usually deals with the number of coins or the one that compares the coins together. And so when I read this problem a little more carefully, they talk about that there are 3 more nickels than dimes. So they did not give us the total number of coins. They did not specify how many nickels or how many dimes there are. All we know is that there are 3 more nickels than dimes. So when I read this, I know that it compares the number of coins. So whenever I'm comparing the number of coins, I know that I can start off by setting each variable, the number of nickels, equal to the number of dimes. But that is not my equation that I'm going to end with. If they are stating that the number of nickels is exactly the same as the number of dimes, this would be a good equation. But they are telling me that there are 3 more nickels than dimes. So I know I have to balance my equation. When I'm setting this up, it's helpful to understand which one of the coins they have more of. So if I'm reading this again, 3 more nickels than dimes, I'm understanding this as that there should be more nickels. And if there are more nickels, in order to balance out the equation, we should be adding 3 to the number of dimes because of the keyword more. And if they're going to be balanced, if there are already more nickels, then in order to balance out the equation, you do have to add more to the smaller amount. So our second equation would be n equals d plus 3. So I repeat, we're going to add 3 to the lesser amount. I'm going to abbreviate amount for us. So remember, if you know that there are more nickels and you want to compare the number of nickels with the number of dimes, the number of nickels, if there are more of them, that can be the single variable, and we will add 3 to dimes, which is the smaller amount. So here we have our system of equations. 10d plus 5n equals 195. That's the value equation. And n equals d plus 3. That's the equation that deals with the number of coins. Keep in mind we named our variables. N stands for the number of nickels, and D stands for the number of dimes. So with this system of equations, we're now ready to solve it, and we have an option. We can either solve by substitution method, or the addition, sometimes known as the elimination method. And when I'm looking at the system, I already noticed that this second equation is already solved for n. So that would probably indicate that the substitution method would probably be the fastest way to go. So I'm going to attempt to do that in a moment. So noticing the second equation is already solved for n, I'm going to take that second equation, and wherever we see n in the first equation, I will plug in d plus 3. So the first equation becomes 10d plus 5 times d plus 3 equals 195. Notice that this equation is now only in one variable, and we will use our equation solving strategies to solve for d. So to do that, we will get rid of parentheses by using the distributive property. So that will leave us with 10d plus 5d plus 15 equals 195. I will then combine my like terms, 10d plus 5d, to give me 15d plus 15 to equal 195. Subtracting 15 from both sides, I get 15d equals 180. And finally, dividing both sides by 15, I will get d equals 180 divided by 15 equals 12. So that tells me right here that there are 12 dimes. And in order to figure out how many nickels I have, I will take my result from the number of dimes and plug it back into the second equation. N equals d plus 3. So I'm going to rewrite that so you can see this. N equals d plus 3. If we know that d equals 12, that leaves us with n equals 12 plus 3, which gives us n equals 15. So that leaves us with 12 dimes and 15 nickels. And that is the solution to our problem.